Hey everybody, this next video lesson is called Combined Gas Law. Now up to this point, we've been talking about, first of all, the different gas variables, pressure, volume, temperature, and number of particles. And then on the next video lesson, we discuss the relationships between pressure and volume, pressure and temperature, and volume and temperature. And we took a closer look at the graphical relationships. What happens to pressure when the volume is changed, or what happens to pressure when the temperature is changed, or what happens to volume when the temperature is changed. But in this video lesson, we're going to talk about a mathematical relationship between all three of those variables combined together, which is why it's called the combined gas law. It has pressure, volume, temperature, all combined into one math problem. Now, I'm going to jot down the formula for the combined gas law, and then we're going to talk about the different parts. On the left side, I have pressure times volume over temperature. And these would represent my starting pressure, volume, and temperature of a sample of gas. And then what I'm going to do is I'm going to change one of those variables, either pressure, volume, or temperature, and I'm going to see what happens to the other variables as a result. And so on the other side of this equal sign, I have pressure times volume divided by temperature. But they're not the same as the beginning. You see on the left we have the starting pressure, volume, and temperature, and on the right we have the final pressure, volume, and temperature. So over the course of this problem, you are going to see the numbers change. And this is why we identify the pressure, volume, and temperature on the left as P1, V1, and T1, and the temperature and pressure and volume on the right as P2, V2, T2. The ones are your starting and your twos are your final. Ideally, we're going to try and solve for one of the final variables. So if I give you a pressure, volume, and temperature to begin with, and I change the pressure and the temperature, you should be able to calculate the volume. Two more things I want to point out is that in some cases, the problem will tell you that a particular variable is being held constant. If a variable is being held constant, for example, temperature, let's say the temperature is held constant at 10 degrees Celsius, well, that means that the T1 and the T2 are both 10 degrees. And if they're both 10 degrees, you can essentially cross them out of the problem, eliminating the need to do the math for those. So anytime you see a variable held constant, cross it out of the problem. The other thing that you need to know is that the different variables have different units, and the different units are clues as to what variable you're looking at. So when you read the problem, you're looking for things like liters, which is a volume, or atmospheres for pressure, or Kelvin for temperature. These are the only three variables I'll use so that it'll make it easy for you to find them. Again, liters are volume, atmospheres are pressure, and K, or Kelvin, is for temperature. Now I'm going to do a couple of examples, and we're going to do lots of practice with this, solving for a missing variable. We're going to read the problem, we're going to insert the variables where they need to go, and solve for the missing variable. And I'll show you how to do this a number of times in this video lesson. First thing I want to do is jot down the combined gas law. It's P1 times V1 over T1 equals P2 times V2 over T2. Now on the left-hand side of this problem, I'm going to list the variables that I know, and I'm going to go back to the problem and look for things like liters for volume and K for temperature. Another K, so I have two temperatures here. Now it says pressure remains constant, and as I told you on the last slide, if something remains constant in the problem, you can cross it out. And so I'm going to go back to my formula here for the combined gas law, and I'm going to cross out pressure 1, and I'm going to cross out pressure 2. Now the things that I have down the left-hand side are volume 1, temperature 1, volume 2, and temperature 2. And since I start with 4.0 liters of gas and 295 Kelvin, those are going to be my V1 and my T1. Now my new volume is what I'm going to be solving for, so I'm going to call that X. And my temperature is now 325 Kelvin. So now I take these numbers over here on the left and I substitute them into the formula V1 times P1 over T1 equals P2 times V2 over T2. But because the P1 and the V1 have been crossed out, I essentially don't need them. So I'm going to put 4.0 on the top, I'm going to put 295 on the bottom of this left-hand side. And I'm going to set that equal to X on the top because I don't know my V2 and my T2 is 325 Kelvin. Next, I need to solve for x, the x in the upper right-hand corner here. So what I need to do is cross-multiply and divide. And you can cross-multiply and divide every time to get this right. So you take the bottom left-hand corner, 295, and multiply it by x. And then I write that down here. And then I say equals, and then I take the 4.0 in the upper left-hand corner and multiply it by 325 here on the bottom right. Now 4.0 times 325 equals 1,300. So that's what's on the right-hand side of this equal sign. Now over here I still have 295 times x. Now I need to solve for x. So I'm going to divide by 295 on each side, because in algebra, if I want to get x by itself, I need to divide by that number, 295 on each side. So now in my calculator, I take 1,300 divided by 295, and I get an answer of 4.41 liters. And that is my new volume. And I double check to make sure that this makes sense, because as we know, if the temperature goes up, the volume should go up. So let's take a look. I started at 4.0 liters, and I increased the temperature by, looks like 30 degrees. Now I increased by 30 degrees, my temperature goes up, my volume should go up. And indeed it does go up. 4.41 is larger than 4.0. So this makes sense. My answer makes sense based on what I know about the relationship between temperature and volume. Here's another practice problem, and I'm going to execute it the exact same way as I did the last one. I'm first going to write out my formula for the combined gas law. P1 times V1 over T1 equals P2 times V2 over T2. Next, I'm going to make a list of variables down the left-hand side of this box that tells me the variables that I know, and I'm going to read them from the problem. So the first variable is 3.5 liters, so that's a V1. Next is 2.48 atmospheres, so that's a P1. Now it says what is the new pressure, which means that's my unknown, or I'm going to solve for x for new pressure, or pressure 2, if the volume is increased to 10.0 liters. Now it mentions that the temperature is held constant, so I go into my formula for the combined gas law and I can cross out T1 and I can cross out T2. Now I list the numbers down the left-hand side. 3.5 liters for V1, 2.48 atmospheres for P1, x for P2, and V2 is equal to 10.0 liters. Then I'm going to substitute those in to the formula for P1, V1, P2, and V2. Next, I cross-multiply, but there's no denominator this time. Because the temperature has been crossed out, I don't need to do any diagonal multiplication. I simply just multiply the two numbers on the left together. 2.48 times 3.5 is equal to 8.68. And I just round my number to past the decimal. That is equal to x times 10, or 10x. Next, I need to isolate x, so I divide by 10 on each side to eliminate the 10 next to the x. And when you take 8.68 divided by 10, the final answer is 0.868. And since this is a pressure, it's in atmospheres, or ATM. And you'd expect the pressure to go down, because if you look closely, I started at 3.5 liters, I increased the volume to 10 liters, and when volume goes up, pressure goes down. Since pressure started at 2.48, it ended at 0.868, and as you'd expect, the pressure went down. Here's my third and final example, and hopefully after you see this one, you'll see that the way that these problems are executed is the same every time. I'm trying to show you a pattern so that you can follow the pattern and show great success. So I'm first going to start by writing out the combined gas law. P1 times V1 over T1 equals P2 times V2 over T2. And now I'm going to list my variables down the left-hand side. And I read the problem. I look for those key units. Volume is liters, pressure is atmosphere, and temperature is Kelvin. So I start reading. A sample of gas has a pressure of 1.25 atmospheres. Now that is a pressure. A temperature of 344 Kelvin. What is the new pressure? Anytime you hear or see something saying new pressure, that's your unknown, or x. If the temperature drops to 249, so that's my T. The volume is held constant. So now I'm going to take these numbers and I'm going to put them in. So P1 is 1.25, T1 is 344, P2 is x, and T2 is 249 Kelvin. Now I can cross volume out of the formula because it is being held constant. Next, I take these numbers on the left and I substitute them in for P1 and T1, P2 and T2. Now I cross multiply. I take 344 on the bottom left and multiply it by the top right, which is x. Next, I take 1.25 and multiply it by 244 and put that down on the right. Next, I multiply my two numbers together. 1.25 times 249 equals 311.25. On the other side of the equal sign, I have 344 times x. Now I need to isolate x, so I'm going to divide by 344 on each side. This eliminates the 344 on the right side, and now I have 311.25 divided by 344. My final answer is 0.905 atmospheres, which is my new pressure. In summary, the repeatable process for solving these problems is as follows. First, write down the law. P1 times V1 over T1 equals P2 times V2 over T2. Second, find the constant variable and cross it out. Third, list the variables down the left-hand side by reading the problem. 4, plug the numbers into the law. 5, solve for x by using cross multiply if there is a number in the bottom. Well, that takes care of this video lesson. Thanks for watching.